Okay, so in this video, I'm just going to do some more examples of implicit differentiation and do some more complicated examples so that you have those to look at. So starting off, we're just trying to find y prime, or another way of writing that is dy dx, right? What we do when we start this type of problem is we take the derivative of both sides. So I'm just going to write d over dx of the entire left-hand side of the equation, and that is equal to the derivative of the right-hand side, right? Okay, now just looking at the left-hand side, what we have first is x cubed times y to the fifth. And since this is a function of x cubed is a function of x, and also y to the fifth is a function of x because y is a function of x. So remember, we're always assuming y is a function of x. Okay. So then we're going to have to use the product rule because it's a product of two functions. We start, now we're taking the derivative, so we can drop the d over dx in this step. So we start by taking the derivative of the first one, that is 3x squared, and then we multiply that by the second function, so we just leave that one alone. And then we add x cubed times the derivative of y to the fifth. And so first, this is going to require the chain rule, and the first thing that we do is take the derivative of the outside function. So maybe I'll make a note here. So this is requiring chain, where the inside function is just y, but remember y is a function of x, and the outside function is, well, I can write it x to the fifth. It's the function that takes your variable to the power 5, right? So we first use the power rule on this, and that would give us 5y to the fourth, and then we have to multiply that by the derivative of the inside function. Remember, that's just y, so we get y prime, right? Okay, so that is the derivative of just this first piece. Then we have to add the derivative of 3x, which is just 3, right? And then on the other side, we have the derivative of 8 times y cubed. So this is really similar to taking the derivative of y to the fifth. So leaving that constant out front, we then take the derivative of y cubed. So that will be 3y squared from the power rule, multiplied by the derivative of the inside function, which is y, or the derivative will be y prime, right? And then we have the derivative of 1, which is just 0, so I'll just write plus 0 there. Okay, now that we've taken the derivative of everything, both sides of the equation, we want to solve for y prime, right? So I'm just going to underline the terms that have y prime in them, right? So those are the two terms, and everything else does not have a y prime in it. So I'm going to bring all of those, so there's this term and this one out front. I'm going to bring those to the right-hand side of the equation, and maybe I'll do this in 2 steps. So if I want to rewrite this with the constant in front, it would be 5x cubed y to the fourth times y prime, right? And then taking both this term and this term to the other side, I would get, I'll simplify this right now. So that would be 24 y squared times y prime. So that's the term that's on that side already. And then we subtract 3 and also 3x squared times y to the fifth. Okay. And now we still have this y prime term on this side. I want to move it to the other side, so I just subtract, and I get this y squared times y prime equals negative 3 minus 3x squared y to the 5th. Right? So now I have a y prime in both terms, so I can factor that out. So I can write it as 5x cubed y to the 5th minus 24y squared times y prime. Right? So then, just to get y prime by itself, all I have to do is divide both sides by this term right here, right? So if I do that, I'll get y prime equals negative 3 minus 3x squared y to the 5th over this whole thing. So 5x cubed y to the 5th minus 24y squared. Okay, wait. I think this turned into a, yes, so my 4 morphed into a 5 along the way, so I'm going to fix each of these. Okay, so it was 5x cubed y to the 4th, so this will be y to the 4th, this will be y to the 4th, and then in here, y to the 4th. Okay, I believe that that is the correct powers on everything. Okay, so this is going to be your answer here. Maybe I'll do this in a different color so it stands out. So, okay, so that is the answer. That is y prime, and our answer does involve y and x, and that's because we're using implicit differentiation, and this often happens when this is the method that we use. Okay, so let's do the next example. So here we have a quotient of two functions of x, right? So in this case, when we take the derivative of both sides, we get something that we have to use the quotient rule on, right? So what happens here is we start with the derivative of the top function. That's going to be 2x. We multiply that by the bottom function, and then we subtract, make that a little straighter, then we subtract the top function, where we leave that one alone, times the derivative of the bottom function. So remember, the derivative of x is just 1, and then the derivative of y, when it's just by itself, we don't need to use the chain rule because that's just a straightforward function of x, and so the derivative is going to be y prime, just y prime, right? Okay, so that is the numerator for our quotient rule. The denominator will be x plus y squared, so just the denominator squared, right? And that is the derivative of the left-hand side of the equation. And then we just have to do the right-hand side. So this is similar to what we did in the last problem. We first use the power rule. So we get 2 times y to the 1. So I'll leave that 1 off. And then we multiply that by y prime. And then this plus 1, the derivative of that is just 0. Okay, so looking through here, trying to identify where we have y prime, we have this term, which includes y prime, and then we also have a y prime here, but it's sort of wrapped up in this product. So what we should do is probably multiply this out so that we can get that y prime term by itself. And just to simplify our calculations, I'm going to multiply both sides by x plus y squared so that we're not dealing with a fraction, right? So I'll go ahead and do that part. So it would be this whole thing. Of course, this is just 0, but multiply both sides by that, and then we would get 2x, I guess I'll multiply this part out as well. 2x squared plus 2x times y minus, so of course the denominator will have canceled, and so I'm just dealing with simplifying the numerator by multiplying it out. We get negative x squared minus x squared times y prime, right? And then on the other side, we now have 2y times x plus y squared times y prime. Okay, and I'm actually not going to multiply out this x plus y squared, just to keep things more compact. So what we have is again, we have this term including y prime, and then this term including y prime, so we want those both on the same side. So I will probably move this one over to the right hand side. So we get 2y x plus y squared times y prime plus x squared times y prime. Okay, and then everything else stays the same. I can actually cancel, so I have a 2x squared and a negative x squared, so I can combine those two and just get x squared by itself, right? Okay, now we just pull this y prime out of here, so we factor it out, and we get this gunk times y prime. And then, just moving this over a bit, solving for y prime, we just divide by that thing we have in the parentheses. So I'm going to rewrite it so I have y prime on the left hand side, and that will be equal to x squared times 2xy over 2y times x plus y squared plus x squared. And that is our answer. Right? So usually these go about the same way. It's just the first step. You have to figure out whether you need to use product rule, chain rule, quotient rule. And then once you have taken the derivative, so sorry, it was in this step here. Once we've taken the derivative, then we're just solving for y prime, and that usually involves taking all of the terms that include y prime to one side, factoring that y prime out, and then dividing to get y prime by itself, right? Okay, so I'm going to stop here, and then we'll do 2 more examples in the next video.